that most of an analyst's time is probably spent data wrangling or manipulating data as you wish. So wrangling, as I said, just reshaping or transforming raw data into a format which is easier to work with. And it's unlikely that the data you import will be in exactly the format you wish for any graphics or modeling or computing of statistics you wish to do later. So it's vital to understand these skills just so we can do interesting things with the data. So we're going to use dplyr. Dplyr is again part of the tidyverse, so you only have to load library tidyverse. And I'd recommend, while I think of it, starting a new script for this session and perhaps saving it straight away. So if either go to File, New, R script, or you can press, if you're fond of shortcuts, you can press Control, Shift and N and it will bring up a new tab. As I said, I'd save that straight away. Multiple scripts within the same project. They're all associated with that project. That means that anything you do in this script, anything that you're loading from this script or saving from this script will R will look for that in your project directory. So the idea is that most of your wrangling puzzles can be solved with just 5 dplyr verbs, and so these are the ones we're going to examine. That will mean that most wrangling tasks will be accessible to you by the end of the day. If you could load the Gapminder package by calling library Gapminder, and then assign Gapminder. So sorry, I'd omitted to do this. Once you've done that, can we do the same as we did for the MPG? That's just examine the data set, have a quick glance at it, see what it's all about. You can do that, I recommend, probably in a new tab by clicking on the names, but actually doing it in the console is also acceptable. We're just looking at probably, well, we know the number of observations, we know there are 6 variables. We want to just understand that understand the variable names too. I think they're more simple in this case. Yes, about 1,700 observations. They are more meaningful than the MPG, and you'll notice, I'll just bring this up quickly. We can also see if we print it to the console, that's by just typing Gapminder and then running that line. We could actually see the type of variable it is, FCT, which is a factor, year, which is an integer, etc. I won't labour that right now. Dplyr, what we're going to do is we're going to use 5 verbs. Those verbs there, arrange, filter, mutate, summarise and group by, and that's going to help us explore this data set. You'd start with 18 and you divide it by 3, then you times the result of 18 divided by 3 you times it by 7, and you subtract 6 and you divide that by 3 and you come up with an answer. So there are different ways of visualizing these steps, and I'm just going to say that we could visualize it like this. So we start with our input, which was 18, and then we divide it by 3, and then we times it by 7, and then we minus 6, and our output is a new number after going through those series of steps. We could also visualize it vertically. So we have our sequence goes 18, then we divide by 3, and then we times by 7. So let's take the mathematical operators outside the boxes, and that's just the same. We get 18 divided by 3, then times by 7. Let's change the operators into English words. So 18, then divide by 3, then multiply by 7. And I just want to isolate the verbs on the side there. So 18, then divide, and then in the box by equals 3. We'll call those the rules. So by equals 3 is a rule, by equals 7 is a rule, and the verbs are on the left there. And then just remove the boxes and replace them with brackets, and that's starting to look a bit more like a function you might give to R. Because I've just replaced then with so then is just a symbol we've given meaning to. I've just replaced that with another symbol, which means then. So 18, then divide by 3, then multiply by 7, and our input number is what we feed it, and our output number comes out after those steps. So what is the output after the first step? If we stopped let's say we stopped our code here, 18, then divide by 3, output is 6. But then the next step will build on the previous step. So this was 6, then multiply by 7. Then the output then is 42. This is how we build our steps in the tidyverse, except that our input is no longer a number, it's a whole data frame. So we take the data frame input, then we do this to it, a verb to it, with particular rules associated with that verb. Then we do next step to it and the rules with that next step. And our output, instead of being a number as previously, is a new data frame. The only difference that I make on this slide is that our then is just this symbol. So data frame, then do this, then do this. We'll ask a series of questions to better understand the data set. And I'm going to look at a verb which will allow us to answer each question in turn. So the first one I want to answer is, how many years does this Gapminder excerpt cover? And we're going to answer this question with the help of the verb arrange. Arrange allows us to reorder rows based on the variable we select. We start with the Gapminder data frame, then we arrange by year. I must tell you before, without further ado, that this can actually be created with a shortcut, so you don't have to type percentage, arrow, percentage. You can just press Control-Shift-M and it will include spaces around that, so that helps with the style. And typically after your symbol here, the arrange comes on a new line, as I have here, indented with 2 spaces. RStudio will do that for you automatically. So this prints the result to the console. If you scroll up in the console, your data will be arranged by ascending year, and starting in 1952, and that will be your first observation for each country. We can arrange in descending order too, and we can do that with, well, I was using this command up until last week, but actually there's a better way. You can just do the minus year. Well, we'll move on to the second question that I'd like us to answer. Which 5 countries have the highest human populations? Should we have a go at doing that with what we've already learned? You probably won't be able to completely answer this question, but I'd like you to have a go. If you've produced that, it's not probably quite what you're expecting, because we want to find the populations in 2007, and if you arrange by descending population, China will dominate but because it's had a record in the last 50 years, so there's a record every 5 years for the last 50 or so years. So that's not quite what we want. We want to remove, or at least we want to select observations that have been taken in 2007. So we want to add a filter, which allows us to pick observations by their value. It works in exactly the same way. We would start with our input data frame, and then we'll filter. What we have to do here is give filter a true or false statement. So actually this double equals here is very important throughout R. Double equals means it's a test of equality. So if you were to type perhaps in the console 1 equals 1, that would return, or should return, the answer true, because it's just testing whether 1 equals 1. Likewise, here we're just going through and selecting the observations where the year is equal to 2007. And it's selecting the rows where that is true. And we can also then add the arrange function to that. We can string it together with the then command. So I didn't actually know that Indonesia had the 4th highest population in the world. If you were to need to refer to that symbol, you'd call it a pipe. And if you were referring to the whole sequence of instructions, you could call it a pipe chain. We're just chaining together commands. Question 3, which 5 countries have the lowest GDP? Have a go answering that question with what we've learnt so far. I feel you won't be able to answer that with what we've learnt. You can't do GDP yet because we have GDP per capita. But we can get GDP from existing variables. Notice we have the population and we also have GDP per capita. What we need is a function of existing variables in order to get our GDP. And that's where mutate comes in. Mutate allows us to create new variables from existing variables. It will create a column on the end of our data set. So what we do is we provide our new column name, the name of the column we want to create. We could have called it anything, but GDP makes sense. I like to name, always use lowercase, always be consistent, because R is case sensitive. Otherwise you have to worry about what case you're using. And so GDP is just equal to population times GDP per capita. And notice we're not testing equality here, so we just use equals, 1 equals. Depending on the width of your console window, it may not show GDP on the end of the data set, but at the bottom it will say 1 more row. Now that we have GDP, we can actually find the subset of observations we have for 2007, and we can arrange by ascending GDP. add a pipe in to the end of the row, and then top n, start typing top, there's there, and then you'll get this top underscore n. You shouldn't have to write underscore, you just press enter when it comes up. And then you just type in 5, perhaps. And hopefully, if my memory serves me correctly, that should give you the top 5. Which country has the highest population for each year of data? Start addressing this with verb number 5. I've omitted verb number 4 for a reason, but verb number 5, summarize, allows us to collapse many values into a single summary value. So we can just take the whole Gapminder data set, then just summarize it so that we can find the single maximum population value. And that will most probably be China, and most probably be the most recent year. And this is how you do that. So like mutate, you'd have your new column name, which I've named population high, and your summary function just tells you, it just gives you the value, which is 1.3 billion or so. It doesn't give you year, and you might need these variables. It's very, very handy. There's no point really in just knowing that piece of information. This is where GroupBy comes in. So GroupBy is the 4th verb. I've labelled them in reverse order because GroupBy always comes before summarize. So GroupBy summarizes is a very, very frequent pattern in R or in dplyr. What we want here is to summarize by year. So for each year, summarize the maximum population. If we wanted to include the country, we'd include it in GroupBy. So we could do GroupBy year, comma, country, then summarize population. If we group by year, we'll get a column by year. And if we group by year and country, we'll get a column for year and a column for country. And then a summary column is created for summarize. We'll get a row for each year group and a value for the maximum population in this case. But if we were to group by year and continent, we get a column for every year and a column for every continent, but we get a row for each unique combination of the grouping variables. So we get 1952 Africa, 1957 Africa. Move on to question 5, which is, how has mean life expectancy in Africa changed over the years 1952 to 2007? So mean life expectancy means we need a summary value. We've also got a number of years here, so we'll need to account for each year. And we've also just got the African continent. So we want to filter observations equal to, so that's double equal, and then inverted commas, because it's a text field, we want Africa with a capital A. You want to do the group by for each year, so group by year. Create a variable name. The argument is, I haven't actually covered this, I've been a bit devious here. There's a function mean that allows you to find the mean of any numerical value. Oh, and the other thing I'll point out is that I've tended to favour this style of naming things. I think it's called snake case, where we separate our words with an underscore. Found the mean life expectancy for Africa for the continent of Africa for each year. So another common pattern is to count the number of rows for each group. How many countries from each continent? Do you want to have a go at that? I haven't given you many clues here. You probably want to group by continent and then use the hints that I gave you there. Selecting the variables that we want. So the columns that we want in the data frame, we just select. So we could do, I haven't given specific examples, but we could do gapminder, then select, what was it, country, and select pop. I didn't originally include select because we've been working with quite small data frames, but when you get data frames that have maybe 20 plus variables, it's a very useful command to just work with the few that you need. To remove one variable, then you put a minus sign before the variable. If I did gapminder then select minus population, it would provide the data frame as before, but without as the original data frame without the population column. 1:4 creates a series 1, 2, 3, 4, and so you could just play around with that in the console. You could do 1:10 or 1:100, and it would create a sequence from 1 to 10 or 1 to 100. And if you wanted to perhaps put a particular variable at the start of the data frame rather than where it was, you could do that. So if you selected pop and then use the function everything afterwards, it would just put pop at the front of the data set. So this is sometimes useful when you've got mutate, which automatically inserts the new column at the end, at the far right of the data set. And so that's a very brief introduction to dplyr.